Welcome to Chemistry 2. Our first topic for this subject will be all about intermolecular forces. First, let's have a review on the different states of matter. As you might remember, this is our first topic in Chemistry 1, and we will also begin Chemistry 2 with a look back on this topic. The different states of matter are solids, liquids, and gases. For solids, the particles are very close to each other. Meanwhile, for gases, the particles are far apart from each other. Again, this is because of the forces between these particles. So there is an attractive force holding these particles together. So for solids, the attractive force is strong. Meanwhile, for gases, the attractive force is very weak. Now let's discuss what type of force is present between these particles. These forces are actually electrostatic forces. Electrostatic forces. Electrostatic forces are, or this includes the interaction between different charges, between negative charges and positive charges. If the same charge, example negative and negative, they repel each other, and the same thing for positive and positive, they also repel each other. Now, if opposite charge, example negative and positive, then they will attract each other. Now, this force between these particles, we call them as intermolecular forces. Intermolecular forces are the forces between these particles. Now, these particles can be a molecule, but it can also be an atom or an ion. Now, we also call intermolecular forces as IMF for short. Now, let's discuss the different types of intermolecular forces. First, let's determine the type of force present between the particles of sodium chloride. This one is your table salt. So NaCl, this one is an ionic compound. This is obvious because sodium is metal and chlorine is a non-metal. So here, this sodium will donate its electron to Cl. So here there's a transfer of electron. So here Cl will become negative and sodium will become positive. So now these are now ions. Again, ions are charged particles. So overall, this one is an ionic compound. Ionic compound. Again, an ionic compound is made up of ions. And here again, these ions are formed due to the transfer of electrons. Now, we have here a grain of salt, or so this very small salt. So this contains a lot of these sodium ions than chlorine ions. Now, let's see how this sodium and Cl are attracted together or is held together in this piece of salt. So again, we have sodium that is positive, Cl, this one is negative, and again, we have a lot of sodium here. Let's take one more Na, then another Cl. Now here, let's discuss the type of force present between these particles or these ions over here. So as you observe here, sodium is positive and Cl is negative. Again, opposite charge, they attract each other. So here, merong attractive force between these particles because again of the opposite charges. And the same thing for here, this is negative and this is positive. So merong attractive force between these particles. The same thing for this one, negative then positive, opposite charge attracts. So this force, we call this force as an ion-ion force. So its name is very obvious because this force is present between ions. So this force is present between the particles of ionic compounds. So that's the first type of intermolecular force, the ion-ion force. Let's have HCl. HCl, this one is a covalent compound here because H is non-metal, the same thing for Cl. So here, there's no transfer of electrons, so walang formation ng formal charges. Again, when I say formal charges, I'm referring to the full charges. So here, there's no formal charges over here. But there might be partial charges on this molecule. We have discussed partial charges on our discussion about polarity of molecules. So let's determine first whether this one is polar or non-polar. And again, we can determine that using their electronegativity. For H, that's 2.1. Then for Cl, that is 3.0. Again, 2.1. then the other one is 3.0. So here they are not sharing these electrons equally. So here these electrons will move closer towards Cl, making it partially negative, and the other side becomes partially positive. So this one is a polar molecule over here. Now let's have another HCl molecule. So here we have H. Again, we have H, then we have Cl over here. Again, the same atoms, 2.1, then 3.0, partially negative. The other side becomes partially positive. This one is also a polar molecule. Now, is there any point of attraction between these two HCl molecules? It's over here, right? Because this is partially negative and this side is partially positive. So merong point of attraction. So here, merong force that will be formed on this side. Again, that's caused by the opposite charges. So we call this one as a dipole-dipole force. Dipole-dipole force. Okay, so this dipole is referring to the polarity on this molecule. So of course, a polar molecule is a dipole. So dipole means from the word di means two, then pole means side. So here it has two different sides. So here we have a separation of charge. So there's a dipole on this molecule and there's also a dipole on this molecule over here. So this force between these two dipoles are called dipole-dipole force. So this force is present between a polar molecule and another polar molecule. Now let's compare the strength of the ion-ion force and dipole-dipole force. Which do you think is much stronger? Is it the ion-ion force or the dipole-dipole force? So it's actually the ion-ion force because this involves the formal charges compared to the partial charges between these molecules over here. Let's continue with HF. So HF, this one is composed of hydrogen, then fluorine. This one is also a polar, right? Because this is 2.1. Then for F, this one is 4.0. So the electronegativity of F or fluorine is 4.0. So this one becomes partially negative. The other side becomes partially positive. Another over here, H. Then we have F over here, H 2.1, F 4.0. So this is partially negative, and this one is partially positive. So here, these are polar molecules over here, polar, then polar. Again, partially negative, partially positive. So opposite charge, they will attract each other. So merong force that will be formed on this part. This is also a dipole-dipole force, pero in this case, this one is a stronger type of dipole-dipole force that's caused by the great difference on the electronegativity between these atoms over here. Again, this is 2.1, then this one is 4.0. So that's a very great difference between their electronegativity. So this one is a special type, a stronger type of dipole-dipole force. We call this one as hydrogen bonding. Hydrogen bonding. So from its name, so this includes the hydrogen. So it's just either bonded to either fluorine or it can also be bonded to oxygen and nitrogen. So just remember this fun over here. So hydrogen bonding is formed when the hydrogen is attracted to either fluorine, oxygen, or nitrogen. So again, this is a special, stronger type of dipole-dipole force. So again, we have ion-ion force, dipole-dipole force, and hydrogen bonding in terms of their strength. Again, that's the ion-ion force followed by hydrogen bonding. The next we have dipole-dipole force.